All right, so starting off, it's factoring having a common term. In this case, we have our 2x cubed plus 24x. How am I going to factor that?
Or you can take out the gx. Oh, I'm sorry.
Is your name, please?
Austin.
Awesome. Can do what now?
They have the x's are similar.
What else?
They are also even.
So they also have what in common?
Two.
Absolutely. As Austin said, our greatest common factor, 2x. 2 in common with both, right? And then x in common with both. So I can rewrite, if I want to, that 2x cubed as two x times x squared, right? Likewise, I can rewrite 24x, since Austin told us that 2x is in common to both terms. 2 goes into 24, 12 times. So here I have my 2x times x squared plus 2x times 12. So we can see that 2x that we have in common, as Austin said, so I just pull that on out. And what am I left behind with? X squared so here I was able to factor that out, coming up with the end factorization end product as 2x times x squared plus 12. What about this one? 4x plus 20x squared plus 32x cubed y. Do I have a GCF here? Austin, only one, folks? Name, please. That's right. 4x. Absolutely. As asterisk or asterisk? Asterisk. As Esther said, 4x, I have a 4 in common with each one of these, 4, 20, and 32, and they all do have that x. So once again, I can write each term as a product of 4x and something else. So this first term would be what? 4x times
1.
Understood 1, absolutely. And likewise, 4 goes into 25 times. And I only have one x already, so I need that other x, right? 4x times 5x, giving me that 20x squared. 4 goes into 32. 8 times. And I still need 2 more x's and a y. Once again, we can see, as Esther said, we had that 4x in common with all of them. So I pull out that 4x, and I write down with whatever is left over. The tricky thing, or it's not that tricky, but the most commonly missed, is that understood 1. Don't forget, we have that placeholder at 1, so there's that 1 plus 5x plus 8x squared y. Is that step needed? Also, for the majority of you, you're saying no. There's no reason to do that. I am showing you step by step everything there is. A lot of times I'm showing a lot more work than you need to. However, just be careful when you do realize, as Esther told us, that there was that 4x in common, and you pull the 4x out, and you say, okay, there's nothing else left in that first term. And you forget there's that understood 1. Right? 15a plus 35ab plus 40b. Name, please. Gabriel? Only 5? As Gabriel said, we have a GCF here of 5, absolutely. A is not shared by all 3 terms. B is not shared by all 3 terms. There's only a 5 in common with those coefficients. So once again, if I rewrite all these using 5 as a factor, I can write it as 5 times 3a plus 5 times 7ab plus 5 times 8b. And then I just factor out the 5 as Gabriel said. Questions? Folks, don't be bashful about asking questions. It's better to ask questions now than ask them during a quiz or test. The difference of squares. X squared minus 25. Is that a difference of squares? Yes. Name, please. Jacob.
Well, because the 25 is something. It's a non-fungible.
So what does difference mean, folks? Subtraction. Well, what does the square part mean?
I'll use the credit.
That's it. Absolutely. It means that each of these terms is a square. Is x squared a square?
Yes, x minus 5, maybe?
We're not getting there yet. We're getting, but no, that's fine. X squared is something squared, right? It's 25 something squared. What? 5 squared. So here I have a difference, subtraction of squares. That's what it means, difference of squares, right? And as Austin?
Yes.
As Austin was saying, we recognize the difference of squares as just once I know what each of those terms are, the ones that are being squared, I just write them down, one of them being plus, one of them being minus.
So they cancel out.
That's what cancels.
Well, to where there's not like, there's only 2 numbers left rather than 3.
Yeah, if I FOIL this out, my outer and my inner term will cancel out. Is that what you're saying?
Yes.
Absolutely. And that is something that Austin's bringing up. When you have the time, folks, can you check the work? Absolutely. You can check the work to make sure we calculated it correctly by doing the opposite operation, which is multiply. Right? Multiply it out. Our x squared plus 5x minus 5x cancels out, leaving us just with a minus 25. Usually you have plenty of time at the end of the test or a quiz. You do not need that time for taking a nap. Utilize that time wisely. Right? Go back, check your answers. What about this? Why to the fourth minus 1? Is that a difference of squares?
No.
I have a no. I have a yes. Name, please. Yes. How so?
This one's squared.
Okay, 1 squared is 1 squared. I mean, 1 is 1 squared. But what about y to the fourth? Yes, test means that. Absolutely. When we raise a power to a power, we're multiplying, so y to the fourth is the same thing as y squared squared, right? So I do have 2 things that I'm subtracting, 2 terms that I'm subtracting, both of them squares. So we have our y squared plus 1, y squared minus. We're done? So, Asher said we're not done? Which one? This one or this one?
No, the other one.
Absolutely. As Asher realized, this is also a difference of squares, so we have to further simplify it. Nothing we can do here. But again, we have our y squared and our 1 squared, so we have our... So sometimes there are going to be multiple steps involved in solving a problem, such as this one. We took it down to a certain point and said, hey, we still have something we need to simplify further. What about the x squared plus 36? Any, please? Danny. Absolutely. As Daniel said, this is not a difference. X squared plus 36. There is nothing to factor here. It is just x squared plus 36, as long as we talk about the real numbers. Next semester, we are going to talk about complex numbers, and you will find out you can factor this further. But as far as real numbers go, that's as far as we can. Quadratics. What is a quadratic trinomial? What does it mean to be quadratic?
It's in two parts.
Okay. When you say you have a quadratic polynomial or a quadratic trinomial, quadratic is telling us that we have
X squared.
we have ourselves a square. Absolutely. Highest power is a square. It has, you said it breaks into two parts. Can you name, please? No. So I said it breaks into two parts, but how do we get in those two parts? Well, there's various ways. You can do the trial method, AC method, you guys are probably familiar with the crisscross method. There's the box method. Numerous ways of factoring these trinomials. A lot of times when we go over stuff, new stuff, old stuff, whatever have you, I may show you one way, possibly two ways. It doesn't mean that that is the way you have to do it. Like I said, I just named off 4 different ways of factoring these quadratic trinomials. Some of you may have learned different than others. How many of you learned the crisscross method? Really? Box method? AC method? Nobody else learned anything else? Trial method? Where you just plug and chug and see what you come up with? What are you talking about? Am I in mathematics? Okay, so here I have x squared minus 2x plus 15. So, I'm sorry, so I said it breaks up into 2 parts. So using the trial method, right, I know I'm going to have factors two binomials here. Where the first part, and let's change this here to a minus. Plus will make it a very challenging problem. So this should be x squared minus 2x minus 15. So within my factors here, what is that first term going to be? A product of what? Factors of x squared. So what times what gives me x squared? What does that minus in front of the 15 tell me?
The sides are different.
I'm going to have different signs, a positive and a negative. What does the minus in front of the negative 2x tell me? When I add, name please, as Christian said, when I add them up, I know I'm going to wind up with a negative. So I have to do my factors of 15, 15 and 1, 5 and 3. One of those factor pairings where when I add them up, as Christian said, I come up with a negative 2. So what's that going to be? Sorry? Negative 5 and positive 3. Right? And negative 5x, positive 3x is going to give me the negative 2x, as Christian said. Right? Once again, we can check our answer and FOIL it out. If I FOIL this on out, I'm going to wind up with an x squared minus 2x minus 15. Over here, let's try the trial method again. What do I know is going in the first positions? X. The only way I can get x squared is x times x. What does the plus 27 tell me?
Are those same signs?
Same sign. What does the plus 12 tell me?
Positive.
Both there with positives, absolutely. So now I need to come up with factors of 27. Yes, sir. Factors of 27. When I add them up, I also get that 12. And as Gabriel said, you're doing right. That's going to be 3 and 9. Does it matter if I go x plus 3, x plus 9, or x plus 9, x plus 3? Does order matter? So here, once again, we come up with this answer. We can always check by foiling it out and out. One more tough one here. Again, the leading coefficient of 1, that's easy enough. You know to start off with the x. And as we did in the first example, we know that that negative 5 tells me I have a plus and a minus. Only factors of 5 are what? 5 and 1. Sorry, name again? Sean. As Sean said, I'm sorry? Negative 5. Okay, we FOIL it out and see that we come up with the exact same thing we were looking for. When the leading coefficient isn't 1, here we have leading coefficients of 2, 6, and 2. It becomes a little bit trickier, so to speak, if we just do the trial method. So if we do the crisscross method, 2x squared minus 5x minus 3. Again, we first list the factors of 2x squared. What times what gives me 2x squared? As Esther said, 2x and x. And then we look at the 3. The factors of 3 are what? 3 and 1 or 1 and 3. We write them down over here. Crisscross method tells us we make that crisscross pattern, and we just multiply x times 1, giving me 1x, 2x times 3, giving me 6x. I know that minus 3 tells me opposite signs. One of them has to be positive, one of them has to be negative. And at the same time, that middle term tells me what I'm looking for. I'm looking for that negative 5x. So who would I associate with a negative? Who would I associate with a positive? Well, with these guys. But you're right. Absolutely. Negative 6x plus 1x gives me that negative 5x, which I needed to find. So the crisscross method tells me I take this plus, put it here, take this minus, I put it here. What are my factors? How do I find the factors from this crisscross method? How do we read it? Somewhere you said you're familiar with the crisscross method. You read straight across, absolutely. Here's my one factor. And my other factor is, so by using, again, you don't have to use this method, folks. If you're able to use the trial method, AC method, the box method, you can use the quadratic equation. Well, that actually does something else. You wind up with a 2x plus 1 times x minus 3 as your factor. Yes. What about this 6x squared minus x minus 2? Can we do the trial method here? Some of you may be able to say, okay. The first one I can't really decide. It's factors of 6x squared, which can be what? 2x and 3x, or 1x and 6x. So there you have a choice, right? What about the last term? Do I have a choice there? No. We know it's a 2 and a 1. I don't know which one is positive and which one is negative, right? But you can play around. That's why it's called the trial method, trial and error, right? You can play around with this, coming up with perhaps you choose 3x and 2x. Minus and plus. If that didn't work, flip them around. 3x and 2x. Or 2x and 3x. If that didn't work, 6x and x. And trial and error sometimes. Does this one work though? Yes. 3x times 2x gives me that 6x squared. My outer term, 3x. Inner term, minus 4x gives me that negative x. Negative 2 times 1 gives me that negative 2. But I've been doing these type of math problems for a long time, so it's easy for me. More patterns, right? Trial method doesn't work. There's the AC method. There's a crisscross method. Well, however you guys learn how to do this stuff is the way that you should attack it. What about this next one? 2x squared plus 4x minus 48. How should I attack that?
Trial method could
Absolutely. Any of those methods could work.
Factor under 2.
As Emily? Really. As Lily said, always look for that GCF. It's going to make your life a lot easier when you factor out, get these numbers to be a lot smaller than what you're going to be dealing with. So in this case, as Lily said, there's a 2 in common. So now what is it that we're looking at? We're looking at factoring x squared plus 2x minus 24, leading coefficient of 1, which means we can easily use the trial method, right? Because we know that both terms are going to be x. I know that one of them positive, one of them negative, and then just factors of 24 where I wind up, when I add them, I wind up with a 2, which would be what? As Astrid did, 6 and 4. 6 times 4, 6 times negative 4, give me that negative 24. And likewise, when I do my outer and inner, we see we come up with that positive 2x. If you did not factor out that 2 to begin with, probably a little bit more trying, use a trial method or anything else. It doesn't mean it's wrong. You're going to save yourselves a lot of headaches, though, if you take out that GCF to begin with. Question? I will try to put up later on today video type stuff of all the different methods for factoring for those of you who need to. The AC method, the box method, crisscross method. When we have 4 terms, can we use any of those? Crisscross method or anything like that? No. The only thing we can do is factor by grouping. Anyone remember how to do factor by grouping? Which one? Those of you who do the AC method, you've done factor by grouping. Turn Rebecca knows. You guess on how we start this off?
Don't you, like, factor the far x?
Absolutely, absolutely. Factor by grouping, we break it apart. We look at the first 2 terms separately and the last 2 terms separately, and we want to go ahead and find that GCF. So looking at the first 2 terms, my x cubed and my negative 2x squared, what do they share in common? X squared, absolutely. So once I factor out the x squared times x gives me that x cubed. X squared times a negative 2, there's my negative 2x squared. Do I have anything to factor out of the next 2? Plus x minus 2. Other than an understood 1. If you did the factor by grouping correctly, what should happen? Absolutely. Inside the parentheses, you are going to have that common factor. So again, each term here has something in common, x minus 2. And what's left over? X squared plus 1. Factor by grouping. This next one, we have x cubed plus 3x squared minus 4x minus 12. What can I do here? Looking at these guys. Absolutely. Once again, there's an x squared in common. And now the second thing, I have a minus 4x minus 12. Which one GCF here? Negative 4. Once again, you can see inside that parentheses we have that common factor of x plus 3. And we're left behind with x squared minus 4. Am I done? Only have one no. Guess everybody else says yes. What do you think? As Sean said, we can still simplify further that x squared minus 4 is a difference of squares. And that's that final answer. X plus 3 times x minus 2 times x plus 2. Lastly, we have 2x cubed minus 10x squared plus 4x minus 20. What should I do?
The GCF is 2x squared, is it not?
For what?
For the first two, for 2x cubed.
Okay, we can definitely do that if we wanted to. Let's hear from someone other than these three. Let's take a look at this last one, folks. What was the very first step we did? And why? We took out a GCF for everything. It made the numbers a lot smaller, a lot more manageable. Folks, there's nothing wrong with what any of you guys said, as far as saying, hey, in this first pairing, factoring out the 2x squared, I can absolutely do that. However, you should always look, make life easy, right? These are GCF for every single term there. A 2, right? So pull out the 2 from everything. And now we're just left with factoring the x cubed minus 5x squared plus 2x minus 10. Is it wrong to go ahead and start doing factor by grouping right off the bat? No. You all just have an extra step or two and some larger numbers to deal with. That's why always look for that GCF. It will make life a lot easier. So now we can say, okay, in this first pairing, x cubed minus 5x squared, I have a
X squared.
absolutely have x squared in common, leaving behind that x minus 5 and the plus 2x minus 10. What do we have there? GCF? 2, right? So we have that x minus 5 in common. Giving us a final answer here of 2 times the quantity x minus 5 times x squared plus 2. Questions? Okay, this should be review, but it's not. If it's not review, now's the time to start studying a little bit more on that. And again, I have tutorials tomorrow afternoon. This is success tutorials tomorrow morning. Don't wait until a test and I don't remember how to do any of that factoring. On the backside, folks, is your homework. You can get started. If you have a few moments, you can start working on it now. When you come in first thing tomorrow, this is what we will be grading. You have your homework and red pen out. Yes, sir. There's only like 5 minutes left of class.